All right, so we're going to be writing a program that produces the nth number from the Fibonacci sequence on demand. So in case you've forgotten, Fibonacci sequence looks a little bit like this. Where every number in the sequence is produced by adding up the previous two numbers, and so on and so forth. So we're going to write a function that, given, let's say 3, 0, 1, 2, 3, it should produce number 2, because that's at index 3 of the Fibonacci sequence. So I'm going to define a function here. And it's going to take in one argument, that's which number of the sequence we want. We're just going to call it n, because it's just a number. There isn't really anything more meaningful I can call it here. Now, so every number of the Fibonacci sequence is based on the previous two numbers in the Fibonacci sequence, which means it's not really clear how to get the first two numbers in there because there aren't two numbers before them. So for just these first two numbers, I'm going to hard code their values in here. So if n is equal to 0, we will return 0. So that's 0 index is 0. Else if n is 1, we return 1. So that's the second item, index 1 of the sequence is number 1. But now after that, we don't have to hard code this anymore because we actually have two previous numbers that we can look at and then add those up to produce the next number of the Fibonacci sequence. So I'll put that in an else. This is for handling any number that's not 0 or 1. We're going to return. So this is where we're going to use a little bit of recursion. I think you might have heard this before. That's just using a function to call itself. So I don't often look for recursive solutions to problems. I usually think that there's a simpler way to solve them, something that's easier to read. But for this problem in particular, I think a recursive solution is very appropriate. It's just really easy to think about this problem in terms of a problem inside of itself. So for any number that's not 0 or 1, we'd use the same process with our same Fibonacci function, looking at the previous number and then the one before that. So let me just test this out, see if this works. So fib4, expecting 0, 1, 2, 3, 4. I'm hoping that should be 3. So I just go to my terminal here. I'm going to run this file with node. And I get exactly what I thought. It tells me 3. Let's try and test that out with a bigger number. We'll go up to 9. So yeah, the 9th number of the Fibonacci sequence should be 34. 8 plus 13 is 21, 21, 13 is 34. So that's what I got. So that's great. So I want to talk about this solution a little bit more, but before I go more in depth, yeah, let's answer some questions. Andrew.
My question isn't about the problem itself. It's about the naming of the function.
That's cool
too. So like the constant fib equals function n. So when you use the constant here, you're using constant just because, just to like clarify, like fib is just a pointer to the function, right?
Right.
But it can also be written the same way that we classically see, where it's function, then fib, and then n is the argument, right?
Yeah, I could also write it as function fib. This is a little bit more old-fashioned, I think, but it's fine. You still see that nowadays sometimes. Depends on the context.
Okay, awesome. Yeah, I've just seen it like different times, and I always get confused every time in like a bunch of different problems when I see the differences between it.
Also, let fib equals function. Not a huge difference between let and const. You know, this prevents me from doing stuff like fib equals 4. I can't assign to a constant variable, so that's what const prevents me from doing, in case, you know, you think someone's going to try to do something wacky later on in the file.
What is the more common way for people to write it now, the classical way or this way that is written right here?
I'd say that this is not uncommon, although maybe arrow functions are a little bit more common these days. So I'd say maybe that doesn't make a huge amount of difference. A little bit later in the program, I'll explain in more depth what the differences between these kinds of arrow functions and using the function keyword. It kind of relates to object-oriented programming, so we'll cover that in a week or two. But for now, they're pretty much equivalent. Does that help? Cool.
Yeah.
Any
Thank
other
you.
questions? Okay, so I've determined that this function is able to produce the correct solution, but I'm kind of wondering how efficient this is. So does anyone have any thoughts? How many times does this fib function get called in order to just produce this one solution for fib 9?
A lot.
That is correct.
Probably like 50 times or so.
I think that's a good guess. How do you think we would investigate that question?
You can add a counter after each before like the return fibs or something.
Yeah, I can actually just put it in the top just to make sure it runs before any of the return statements. You know, I could just do some math and kind of theorize about how this program is going to run, but it's easy enough to just put a counter in and have the computer tell me what it's doing. So let's say counter equals 0. And then first thing here, we're going to console.log counter plus plus. So every time we call this function, we're logging our counter and then also incrementing it simultaneously. So because we have the plus plus here, this is actually reassigning it a new value. You know, so I could have also done equals and something like that. That would be equivalent. So let's see. So for fib 4, okay, yeah, sorry, it's getting a little weird because this console log is showing up at the end of it. So this is the result of fib 4. This is our counter counting up. So it looks like we did 8 calculations, 8 function calls in order to just find the 4th number of the Fibonacci sequence. So let's go just a little bit further. I'm going to look at the 9th item of the Fibonacci sequence. Oops. Run that again. Okay, so now this is a lot bigger. We can see our counter counting up. Didn't seem so bad just for the 4th one, but then for the 9th one, we're doing 108 function calls to get this done. So part of the problem here is this recursive algorithm is really redundant. I'm doing a lot of the same work over and over again. So in order to solve, in order to solve for fib 9, I have to know fib 8, and then also fib 7, because those are -1 and then -2 from fib 9. But of course, in order to solve fib 8, I have to solve fib 7 and fib 6. In order to solve this fib 7, I have to solve fib 6 and fib 5. So it gets this kind of like tree structure, whereas every call has 2 more calls inside of it because of this return statement that calls fib twice. But you can see that there's a lot of repeated calls here. So n-2 from fib 8, that's fib 7, that's the same as, or I'm sorry, n-2 from fib 8 is fib 6. That's the same as n-1 from fib 7 is fib 6. So this is the exact same function, the exact same calculation, happens multiple times in the course of solving this one problem. So while this does work, and I think it's cool if you're able to understand this, understand recursive programming, because it's a useful technique to know about. And it's certainly one that interviewers will expect you to know. You'll probably be asked questions where they're just hoping you'll come up with a recursive solution to the problem. Sometimes it's not the most efficient way to solve a problem. And I also don't think it's necessarily the easiest kind of solution to read. But so for now, let's try to come up with a different solution to this problem that doesn't require us to do hundreds and hundreds of calculations. So I'm going to comment this out. So first time we did this, we were taking kind of a top-down solution, where if we're told to solve for fib 9, we pass in fib 9, and then our program tries to solve for fib 8 and fib 7, and then fib 6, all the way down to the bottom. So now I'm going to do that in reverse. I'm going to solve the smallest problems first, and then go up to the number that was actually requested. So one of the things that's going to make this solution much more efficient is every time I calculate one of the Fibonacci numbers, I'm going to store it in an array so I can remember it for the rest of my program, instead of recalculating these solutions over and over. So I'm going to start with an empty array, so I can fill that up with some information. And now I'm going to do a for loop, starting at 1 and then going up to n, the number that was requested. Because I'm not going to just directly solve the Fibonacci sequence for the number that was asked for. I'm going to have to figure out every number along the way up until the one that was asked for. So we'll start a for loop. Just your basic for loop from I to n. Now again, I have to hard code the first 2 items of the sequence, because I need to look at the previous 2 items, and for the first 2 there aren't 2 previous items. So we're just going to hard code this. So we'll say if I equals 0, solutions.push 0, 0. I is 1, we'll push 1. And then for any other number, we just have to push in the sum of the 2 previous numbers. But fortunately, those previous numbers are all in this solutions array, so we can just refer to that instead of actually calling our function again. So the previous item in this array is going to be solutions, and we use bracket notation to get the previous item. And then we're going to add that to the item that was 2 before it. So now let's just look at what our array looks like before we actually return an answer. Oh, I need to actually call my function. That would help. All right, so now I've got a full array of the Fibonacci sequence up to the 9th item. I think there was a hand raised.
Yes, if we're doing for efficiency, rather than having the first two if-else statements, why don't we just initialize it to 0, 1? That way we don't have to worry about those checks.
You mean just starting off with an array like that?
Yeah, that way you don't need the first two if-else statements. And you start your for loop at 2.
That's also perfectly valid. I guess it depends on your sense of aesthetics. So I prefer doing this way because it lets me have the simplest for loop possible. I'm starting at 0, I less than n, I plus plus. This is like the most basic for loop ever. It doesn't get any simpler than this. I like starting with an empty array, and I don't mind hard coding a couple cases. You might think differently. You might think that hard coding these first 2 items here with the if else statements looks ugly. You can even put them into one line like this so that they're a little bit more dense, but you still might not like that you still might not want to have that there. So it's really just a personal preference. I would totally accept a solution like this that started out with these 2 items pre-filled in the array, and then you do a for loop starting at 2. But I don't know. This just seems prettier to me. I think it's easier to read. But good question though. Jin, did your hand go up?
Yes. Could you repeat what was happening again on line 41?
All right. Yeah, so this is really the one line that solves most of the problem, where after we've already got the first 2 items of our solutions array, every successive item after that, we can figure it out by just adding up the previous 2 items. So since we're doing our for loop with I is always going to be the current index of our array that we're looking at. We can get the previous 2 items with I minus 1, or solutions at I minus 1 and solutions at I minus 2. So that's the previous item and then the one before the previous item. So adding those up should give us the next item in the sequence, because that's just how the Fibonacci sequence is defined. Sound good?
Thank you. Yep.
Any other questions?
Yeah, I just want to bring up something about like hard coding the 0 and 1 in solutions originally too. So if you do that, it does work. But if you're not thinking properly and you put in n equals 0, it's going to return 0, 1 for the Fibonacci sequence, which like will confuse you in the first place. So like, even though it does shorten the code, there's like a different scenario you have to think about too.
That's a good point. I didn't even think about that. But in general, that is a consideration that you should be thinking about when you're writing code. Just what's the worst that could go wrong? How could someone else misunderstand my code? What terrible mistakes might they make if they do misunderstand my code? And will it be my problem to fix that then? So I often try to write my code in as simple of a style as I can. Just, make it easier to fix things down the road. All right, so I've been coding, I've been talking. Let's see if this actually works. Oh yeah, so I'm not actually returning anything here. So I'm going to call solutions.pop. That's going to remove the last item from the array, which in theory should be the nth item that was requested, and then return that. So that's what we're going to console log. Gave me 2. So it seems I have an off by 1 error, gave me 2, should have given me 3. What am I doing here?
Wouldn't it be I is smaller or equal to n? Wouldn't that fix the error?
Maybe. Yeah, let's go with that. Thanks. So very common error in programming, an off by 1 error, they call it. I wrote less than when I meant less than or equal to. So now we're actually going the proper length, iterating the proper number of times. So fib4 shows me 3. Let's try that again. Fib9 gets me 34, so it looks like it's correct. But now I'm curious about the efficiency of this algorithm, wondering how many function calls or how many iterations of this loop do I have to do? So that's kind of the fair comparison here. Here, I'm just looking at the total number of function calls. Here, I'm doing one function call with a loop. So I want to see how many iterations of this loop am I doing? So that's just going to be I, because I gets incremented for every run of this loop, every iteration of this loop. So I'll just console.log I, see what that looks like. And it's much smaller. Calculating the 9th item of the Fibonacci sequence took 9 iterations of the loop. So that's much more efficient. It, this isn't going to grow wildly out of control if I need to calculate a much later item in the Fibonacci sequence. Like, let's say I want to calculate the, I'm afraid of picking a number too big here. Let's say I want to get the 32nd number of the Fibonacci sequence. So it's still, less than a second. Maybe you saw like a millisecond there before the output came out, but it's still pretty quick to get me this 7-digit number. So I'm going to try the same thing again with my previous algorithm. So this is the old recursive algorithm I was using before, but we're going to go up to 32. And we go. And we're going. And it's still going. And we're counting. I actually don't know how long this is going to take, so you can like ask questions now. Jin?
For learning purposes, when we're doing our challenges, will you be expecting us to be trying to solve them efficiently, or just making sure that we kind of get the answer first?
Get the right answer. That is by far more important. The Fibonacci sequence is an interesting and famous problem for a lot of reasons, and most of the problems that you will solve as an engineer will not be this interesting and will not have such complex solutions. It's not going to be quite so easy for you to write such a poorly performing algorithm as what you just saw me do. So generally speaking, if you can get the right output, it's probably fast enough. Modern computers are very fast for most things. Any other questions?
I had a question, if you don't mind me asking.
Go for it.
So I was curious what the performance difference, if there'd be any difference, for storing the last 2 numbers and like their own separate variables. So like just having like a variable A and B and storing the last two numbers in those instead of like having all the numbers in one array, that would make a difference at all. If like how like the push method, if that's like more costly than just like restoring the numbers and variables.
Yeah, so that's a really interesting question. Oh geez, I think my machine is like freezing. I'm just gonna crash out of this loop here. Sorry, when my terminal unfreezes, I'll answer your question as best I can. Or maybe I just should close out of here. Yeah, sorry, my terminal is not responding, so I'm gonna have to force quit it. Okay, let's try this again. So yeah, anyways, lesson being here that the recursive solution was so inefficient that it crashed my terminal, whereas this solution with a simple for loop and remembering the previous solutions without recalculating them was able to do it in a fraction of a second. But so your question was about the efficiency of storing only the last two numbers instead of storing the whole array.
Yeah.
So this is something we're going to talk about a lot more in later weeks, so I'll try not to get too deep. But when we're talking about performance efficiency, there are generally two kinds of efficiency. You're talking about time efficiency, which was mostly what I've been talking about here, trying to get your program to run faster. But there's also space efficiency, getting your program to use less RAM while it's running. And usually I don't care as much about the second one. Usually, the RAM doesn't grow as your problem continues, as your problem gets bigger. You don't have to think about it as much. You generally have enough RAM, and the time is more important because you can always do more things in the same amount of time if you do it faster. But in this case, you're right, this array is going to get really big as I'm calculating larger and larger numbers. So if I was being sensitive to the space efficiency as well as the time efficiency, I could probably come up with a better solution by only storing the last two numbers of the array, because calculating any number of the Fibonacci sequence only requires the previous two numbers. So once I've gotten the third number of the sequence, I can get rid of the one that's 3 before it. So I'm never dealing with an array that's more than 2 or 3 items, but I can still get the solution pretty quickly to a large number. So yeah, that's a good question. We'll definitely talk about that more in a couple weeks.
Thank you.
Bao, do you have your hand up?
Yes, so I have a question about the terminal. If we stuck in a infinite loop, is there like a command or any shortcut can exit out of it instead of closing the terminal?
Yeah, so first of all, what system are you on? What's your operating system?
Mac OS.
Okay, so Control C is kind of the generic force quit, crash out of a program. So yes, that's control, not command. I know you're on a Mac, but at the terminal, you use Control C to just stop whatever you're doing. I was kind of surprised in this case that did not work for me. My terminal was not even responding to the force quit signal. So I had to do Command Option Escape is the force quit on Mac. It's like the Mac equivalent of Control Alt Delete, basically.
All right, thank you.
Yep. Any other questions? Questions going once, going twice? No? All right, cool. So thank you for listening, paying attention, asking questions, everything. That was my demo of the Fibonacci sequence. I'm gonna stop sharing, stop recording here real quick. All right, so this morning, we're gonna be learning about some introductory Python syntax. I know that yesterday you covered JavaScript fundamentals, so this is gonna honestly be very similar, because most programming languages are pretty similar, to be honest. So I'm going to be kind of glossing over some of the things that are very familiar to you based on having just learned JavaScript yesterday, but I'm going to take a little bit of extra time to point out some things that are different about Python that might be surprising to you if you just learned JavaScript first. So Python, like all programming languages, you're going to be manipulating various types of data, such as numbers and lists. If you want to understand how you can manipulate your data and compare it to other data, the most important thing that you have to understand is the type of your data. So many of these types are similar to the types we use in JavaScript, but there are a few important differences that I want to point out. First of all, there are two different types of types. I'm going to talk first about primitive types, which is just a single value, and then also non-primitive types, which can contain other values. So let's make a place for this. Make a file for notes and make a Python file that we can execute. Hang on a second, just fighting with my editor here. Okay, so first of all, two types of types. Primitive types, such as numbers, strings, Booleans, just single values.
Hey, Raphael, are you sharing your screen right now?
Oh my gosh, I'm not. I'm so sorry.
No worries.
Okay. Okay. So there are a few core primitive types, such as numbers, strings, and Booleans, and then a larger number of non-primitive types that can be used to contain some of these primitive types, such as lists and dictionaries. So just starting simple. Just going to create a literal number here. By literal, I mean that this is just the simplest way I can represent a number in Python. You can have variables that refer to numbers. Numbers as part of arrays and dictionaries and whatever. But for just the simplest way I can represent a number literal, you just type out the number 4. And you'll note in Python, in order to assign a value to a variable, it's just a simple equal sign. There's no keywords used, no like let, const, or var or anything. Python is a little bit simpler in that regard. And also the naming convention is a little bit. Python variables use what's called snake case, which is just lowercase letters separated by an underscore. So this is one quick way that you can tell, what programming language you're reading just by the style of the variable names. Python code should stand out pretty quickly because of all the snake case names, whereas JavaScript code should stand out to you because of all the camel case names. All right, so now just talking about types before and how important it is that you know what type everything is. Now, if you don't know what type something is, you can just ask. So there's a built-in function in Python called type, which tells you the type of things. We'll talk more about functions in a minute, but I can type, put some parentheses here, and then put in any value, put in a reference to this number, and I'll see what Python thinks it is. We also need to print it in order to actually get that on the screen. type just returns a value, but doesn't do anything with it specifically. I want to print it. We'll run that file. And it tells me it is an integer. Cool, that's about what I was expecting. So just like in JavaScript, there are a whole bunch of operators that you can use to operate on numbers, such as plus, minus, multiplication, division, modulus, greater than, less than, strict equals to, whatever. This works pretty much the same way it does in JavaScript. It also works pretty much the same way it did in your 6th grade math class. So I'm not going to spend too much time reviewing that right now. But one thing that I do want to point out is that Python does not have any type coercion. So in JavaScript, we talked about type coercion the other day. If you try to compare two values of different types, JavaScript will try to convert them to the same type in order to make that comparison. So typically this means converting both values to strings and then comparing them, which is often not what you want. So Python, in contrast, does not do this, which means that we don't need to have special operators in Python for dealing with type coercion. So remember, in JavaScript, we have the double equals and then also the triple equals. We've got not equals and then also the double not equals. So that doesn't exist in Python. Python comparisons are going to be simpler. So, we've just got the double equals and the not equals. There's no triple equals in Python. So all comparisons in Python already can only compare things of the same type. All right, so that's about as much as I have to say about numbers in Python at this point. Let's talk about strings a little bit. So a string is just a series of characters. Just like in JavaScript, we can enclose them in single quotes. Or double quotes. You can use either. It doesn't really matter, or at least Python doesn't care which one you use. They're interpreted the same way. Just know that you can't put, double quotes inside of double quotes or single quotes inside of single quotes, because that'll end the string. Because now my editor thinks that this is not part of the string anymore. So I'd have to escape it or, do other things. Ankur showed you this the other day in JavaScript. It's the same problem, basically. So let's just confirm now that my computer thinks that this is the same type that I think it is. Print type, another string. And that is a string or an str. So that's roughly what I was expecting. So that's good. It's always great when you can confirm your expectations. Now I'm going to show you something a little bit more advanced. This is how we do string interpolation in Python. We showed you string interpolation in JavaScript, and so this is going to be the same concept, but the syntax is a little bit different. So if I have a string that I want to insert variables in the middle of, you just put a letter F and then you start your string. So you see right now the F is white. I put in the double quotes and it turns blue. My editor has recognized this, that the F is like part of that string. This is called an F string. Now, if I have any variables, I can put them inside of her really easily. So let me just define some real quick. All right, got a little sentence here, but there are placeholders. Got these variable names with the curly braces around them. So that's similar to how we did it in JavaScript. We had the dollar curly brace syntax. Here it's just the curly braces. Then we also have the F in front of it. And we can use the regular double quotes instead of backticks. So there are a few cosmetic differences, but it's mostly a pretty similar concept. Let's just see that in action real quick. Cool, let's go bowling on Friday afternoon. I have successfully interpolated variables into my string. So that's how that works in Python. Shouldn't be a new concept, but the way you do it is a little different. Ivan, you have your hand up?
Yeah, so I remember I was taking a Python class. There's like the OG way to do it, where it's like string format, and then you pass whatever you put in there, what's going to be formatted. They were saying, I remember in the video, it was saying like there's still some applications where you use the ancestor way of like saying string format and then the things that you're passing through the string instead of just doing the shortcut.
Mhm.
I don't know if like you've seen it actually applied where you can't use the shortcut way, you actually have to use the other way that they use. I don't know if that makes sense.
Yeah, I hear what you're saying. So the short answer to your question is I don't know. I'm not exactly sure why you would need to use the long form of that. I could imagine though that this shorthand syntax is probably not very flexible. Like I think all I can do with this syntax is just put variables into my string, which I mean is useful, but maybe the format function like takes multiple arguments, maybe it takes optional arguments, maybe has different modes that it can work in. So since it's a function instead of just, this F syntax, it's possible that it has a lot of other options for more like less common needs, I suppose. But I could look into that and possibly get you a better answer in the future.
Thank you.
Do we have another hand up?
Yeah, I had a question. You said earlier, so Python doesn't have type coercion. So if you change the variable day to an integer and then you switched it, when it puts it in the string, is it switch automatically over to string?
So you're saying like day equals 12? I don't know. Let's see what happens. So yeah, I guess in that case, it'll convert it to a string to put it into the string. But I'm trying to compare things. So like, I don't think there's any way that I can get Python to tell me that these two variables are equal to each other. Since they're different types, there's just no way they could be the same value, even though they kind of look similar to my eyes. Like Python knows that this is a number, this is a string, they're just not comparable. Whereas JavaScript tries really hard to do what you ask it to, even if it doesn't quite make sense. That's kind of the difference with JavaScript being primarily a front-end language. Since it's supposed to run in the user's browser, it's closer to the customer. It's thought of as like less acceptable for JavaScript to just throw up its hands and be like, I don't know what's going on, I can't do it, sorry. And so JavaScript really doesn't want to crash. It really tries to do what it can. Whereas Python is more of a backend language. It's supposed to be more correct, I guess. And so Python is more inclined to throw errors and be like, no, that doesn't make sense. Like, fix your stuff and then try it again. Any other questions before we move on? No? Okay. All right, so very briefly, there's one last primitive type I want to talk about. I'm going to talk about this for like 10 seconds, but Booleans in Python work basically the same way as in JavaScript, except we spell them differently. With a capital T and a capital F. Otherwise, it's exactly the same as in JavaScript. But this is definitely something that's thrown me off in the past, just forgetting to capitalize my T's and F's coming from different languages where it's spelled a little bit differently. So that's just something to keep in mind. So for right now, that's actually all I have to say about the primitive types in Python. We're going to start talking in a minute about non-primitive types, lists and tuples, all that fun stuff. But does anyone have any questions about this simple stuff before we move on?
I have a question about the difference between Python and JavaScript. So it seems like you don't put semicolons after your statements in Python.
Correct. Yeah, so Python is white space sensitive. I was going to bring this up in a minute, but since you asked, I'll just say it now. Python is, call it white space sensitive, which means that the boundaries of your program are not marked by semicolons and braces like in most programming languages. Okay, but so instead of semicolons and braces, these boundaries are marked by new lines and indentations. So, a semicolon in JavaScript would be like a new line in Python. A curly brace in JavaScript would be like an indentation in Python. I think I got that right. Maybe it's not a perfect metaphor, but the point is that Python enables you to write with less punctuation, less syntax, but you have to keep the indentation correct in order for the interpreter to know what's inside of what. In my mind, it doesn't really matter that much because you should always be indenting your program correctly, regardless of what the programming language requires of you. Because it's true that in Python, if you don't indent your code correctly, the interpreter can't read your code. But like in JavaScript, if you don't indent your code correctly, I can't read your code. So that's also a problem. And your editor has the built-in auto format thing. I think it's like Shift Command F or something. Maybe it was not that button, but there's the prettier beautify package that Ankur might have suggested you install. And there's also some default functionality for that in VS Code. So if you're not exactly sure what proper indentation looks like, there are some tools that can help you out, but it shouldn't be just like the Wild West of random indentation levels all over the place. Does that help? Does that answer your question? Cool.
Yes, it is.
Anyone else with their hand up here?
Yes, Raphael. I have a really basic question about
Sure.
the string interpolation. Will the spacing within the sentence be affected by if you accidentally type a space before or after the string that you put within the curly bracket? Will that affect the spacing at all?
In the curly braces you're saying here?
Yes.
So that should not. This is just like an artistic choice that I'm making here to put a whole bunch of spaces, but it shouldn't affect how it actually prints out. Yeah.
Okay, thank you.
Whereas putting spaces here, that should actually do something. Yeah. Good question. Do we have any other questions?
I have a question.
Mhm.
Where are you testing like your console, or are you going to live server?
This is just my terminal. It's the built-in terminal on Mac OS.
Okay.
CD'd into the project folder where I've written this file, this main.py. I can just less main.py, and you see this is the same file that I'm working on over in VS Code. Press Q to get out of there. And then I'm just running it at the command line with Python main.py.
Okay, cool. Thank you.
Yep. I, as much as possible, try to do everything at the command line. I just like it. It's comfortable. It's convenient. It works the way I want it to. It doesn't change when I don't want it to. Like nobody forces updates on me that, change the terminal interface or whatever. Honestly, I do a lot of my developing in the terminal too when I'm not like presenting to other people, but it probably would look weird if I did a full lecture in Vim, so I'm not going to do that. All right, so I've been chatting for a little while about primitives in Python. It's 10:12 now. Let's take an 8-minute break, come back at 10:20, and I'm going to talk about lists.
Hey, real quick, I just got a quick question.
Sure.
So the print function here, whatever it's called, is that like the equivalent to console.log, or is that
Yes.
equivalent to a return? Okay.
It's the same as console.log. Print does
Okay.
not give the values to any other part of your program. It just displays it visually for you to debug and develop.
Okay, thank you.
You're welcome. Hello, class. Welcome back. Hope you had a relaxing break. So now we're going to start talking about lists. So I know in JavaScript, you've already been using arrays, which is, how you store a list of things in JavaScript. Lists in Python are pretty much the same concept, except they have, I think, a more descriptive name. They're actually called lists, which is what they do. The syntax is pretty similar also. So I'm just going to define a list for you here real quick. All right, so I've got a list of berries, everyone's favorite type of fruit, which we all understand very well. So I want to see what type of variable this is. Again, Python can tell me. Let's comment out some of this other stuff. Don't need a million, don't need a million logs. All right, so I'm looking at the type of berries. It is a list. So Python is confirming my expectations. If we want to access some items from this list, it's going to be pretty similar to how we access list items in JavaScript. So if I print berries1, what item should I expect to see in my console? It's pop quiz. Anybody?
Tomato.
Yes, we're going to see tomato. Index 0 is grape, index 1 is tomato. So that's what I'm really hoping to see in my console, or else I've done something very wrong. Okay, great. So there's tomato. So that should all look pretty familiar to you based on JavaScript. And this is where we're going to leave JavaScript behind. Now we're going to do a whole bunch of cool things that are Python only. So you might in your career at some point meet people who are like really enthusiastic about Python. They think it's just the greatest and best programming language ever, and they'll like never touch anything else. Generally, the reason why they like Python so much is because of lists, because they love the kinds of things I'm about to show you that Python can do really easily that is just kind of awkward in other programming languages. So let's say I wanted to get pumpkin, so I just printed out tomato, but instead I want to print out pumpkin from this array. How do we think I should do that? What am I looking for here? Any
You can use
thoughts?
-1.
I can, because I'm using Python. So that's a nifty feature that I really miss in JavaScript. Python supports negative list indices. Indices, yeah. So the equivalent JavaScript code would be something like log berries, and then I have to access the length of the array and then get the number that's one less than that. Because the actual length of the array is going to be one further than what's actually in the array. It's going to be out of bounds. So I have to get berries at length -1. So this code here in JavaScript is equivalent to this code here in Python. I prefer the Python version a lot. I really wish JavaScript had negative list indices, but it doesn't. So that's one really nice thing about Python. Sorry, hang on a second. Okay, but it gets even cooler than that. So there's also this concept in Python of slicing lists. That's a way that you can just take one subsection of a list. So in JavaScript, we can do similar things. We have a method called slice. That returns a part of a larger array, like the first half or the middle 5 items or whatever. You can do that with JavaScript slice. So there is a function that does similar things, but in Python, this is a built-in language feature. There's like built-in array list syntax that lets you do this, and you do that with a colon. So if I want to print out berries, so 2:4, this is going to give me a new list. So this slice syntax here, it creates a new list that includes index 2 from berries and stops just short of index 4 from berries. So 0, 1, 2, I'm expecting cucumber, 3 is eggplant, and then stops right before banana. So I'm expecting cucumber and eggplant to get printed out when I'm looking at berries from 2 to 4. Cool. So that's what I got. Sliced from the middle of the list. If we just want to start, if we want to just slice from the very start of the list, there's a shorthand syntax for that. So by just not putting in a first number, it assumes start of the list until index 3. And then similarly, if we have a number and then a colon with no number after it, that means get the second item until the end of the list. So I don't even have to know how long the list is. Just ending it with a colon means go until the end. So let's see here. Berries :3. This is, where is it? Yeah, grape, tomato, cucumber. So this is from the start to index 3. And this is from index 2 until the end. So a lot of the work that you're going to have to do in general as a programmer, no matter what language you're working with, is just manipulating arrays, sorting them and filtering them, adding and removing items from them, comparing one array to another, whatever. That's a lot of the work that you do. So you need to be good at your programming languages provided tools for manipulating arrays. And so if you're going to be doing most of your work in Python, it's really great that Python provides you these really powerful tools for manipulating arrays. I know if you haven't seen a lot of this syntax before, it can get really dense. Some people get carried away and will do like a lot of really sophisticated array manipulations in a really small space, like in 2 lines of code or whatever. But if you know what you're doing, it's very powerful stuff. All right, so we're going to come back to lists a little bit later in this lecture, but we're going to move on for now to tuples. Does anyone have any questions about these list basics that I've shown so far? Should be pretty familiar based on the JavaScript arrays that you worked with yesterday. Questions? Going once, going twice? Okay, cool. So next up are tuples. So this is a concept that does not exist in JavaScript. They are like lists with one critical difference. So the single biggest difference between Python tuples and Python lists are that tuples are immutable. Has anyone heard that word before? Can anyone tell me what that means?
It just means you can't change it, right?
It does mean that you can't change it. There's a slightly different definition that I prefer. So an immutable value in programming cannot be mutated. I like defining it this way because I just want to show you that this is a word you probably already know. It's just kind of conjugated into a strange form. You know, you've all heard of mutations before, but immutable is sort of a strange word maybe when you encounter it for the first. But I just want to impress upon you that this is a word you already know. It just means that the data cannot be mutated. It cannot be changed into some other form.
The reason we use mutated over changed in that sentence is because mutated denotes the originality continues in line, whereas change denotes a totally new change of structure.
I'm sorry, are you reading that from somewhere? I don't know.
I'll have to pull the source for you.
I don't know if I've heard that before. I've never thought of change and mutate being too terribly different. I just like explaining it in terms of, you know, the original word. But that's an interesting distinction. I'll have to think about that a little more. All right, so since tuples, actually, so one more point about names and terminology. Does anyone have any theories, hypotheses about why these are called tuples? Like, it's kind of a weird, goofy name, isn't it? Does anyone think about where that came from?
It's the last letters in multiple, right?
Yeah. So a tuple can store maybe, you know, a triple data. Or maybe, you know, some quadruple data. You know, pentuple data, whatever, some multiple of data. So I still think it's a little silly, but now you know why they're called that. Maybe it helps you remember it a little bit better. That's why they're called tuples in Python. So because you can't change them, I tend to use them a little bit less often than lists. They're used for, I mean, on the rare occasions when you have data that just should not change. And normally, the reason why we're writing code is to change data, manipulate values, and calculate things. But there are some situations where it just doesn't make sense for your data to change. Like, let's say I'm doing some loop over days of the week. I might store that in a tuple. All right. So, maybe I have to do a loop or something if I'm like building a calendar widget. I have to do something for every day of the week. I don't know. So I'm going to do a loop for 7 days. And I need to look at Monday, Tuesday, Thursday, Wednesday, etc. for every iteration of the loop. But there's no reason at all for this array to change, unless there's like a change in the leaders of the Roman Empire or whatever. You don't usually change the calendar in such dramatic ways. I'm reasonably confident that by the end of my career, these are still going to be the same 7 days of the week. So there's no reason why people should be adding or removing values from this tuple. So just to show you what a tuple forbids you from doing, let's say I want to change the days of the week. I don't like Sunday anymore. I'm going to say after Saturday, we get Catterday. But if I try to run this, Python is going to throw an error. Tuple object does not support item assignment. Once I've created a tuple, it cannot be changed at all. I have to just create a new tuple if it needs to be different. Porfi, you got a question?
Yeah, so I saw that the rest of the program ran and then you got the error.
Yep.
Is that just because of how Python is interpreted?
Right. So, because it's not compiled, it's not like Python is evaluating my entire program to make sure it makes sense before it runs it. It's just going to start at the top and then go line by line as best it can. And all the stuff at the top makes sense. So the Python interpreter is able to execute this code just fine. It's not until it gets down to here to line 47 that I ask it to do something illegal. So it throws an error at that time and not before.
Cool. Thank you.
Yep. So another example that I kind of like to think of in terms of why tuples might be useful is for geographical coordinates, latitude, longitude, whatever. So, location equals I don't actually know what latitude and longitude coordinates should look like. So this is probably somewhere in the world. But the point is that even though that this is a collection of 2 data points, it's not really 2 data points. It's really just one place. It's one location in the world somewhere. And so it wouldn't really make sense to modify one of those items without modifying the other. If I wanted to get a new coordinate, I would just create a new tuple entirely and just throw this one out. So for data where it doesn't make sense for it to change, you need to all stay together. Tuples are sometimes useful for that. I honestly don't think about them all the time, but I see them often enough in like other people's code. So I think it's pretty fundamental. You should understand what they are, not be surprised when you see parentheses and closing a list of values. Do we have a hand up? Brendan?
Yes, I have a question concerning these tuples, and I guess you can, and I'm just imagining, you can push stuff to lists in this, but you can't push stuff, even if it's an empty tuple, like you can't, or there's no reason to make an empty one like you would an array. In
I want to say
JavaScript, I
there's
guess.
no reason, but I'm struggling to come up with an example. So typically you would not want to have an empty tuple, and you're right, you can't add items, you can't push items to a tuple. So if I try like days of the week dot append should be the name of the method. Yeah, tuples do not have an append method. Lists in Python have append. That's how you add things to the end of them, like push. But tuples do not. They just don't have all those list methods that modify the list. Bao?
Will you still be able to use a slice method to represent part of the tuple value total?
Maybe, I don't know, I haven't tried it. It seems reasonable because it should create a new list or new something instead of modifying the original. But let's see. So if I say weekend equals days of the week. Looks like it, yeah.
Okay, thank you.
So let me just remove these console logs here just for clarity. But yeah, so I just tried to use that slice syntax that I was using for lists before, tried on this tuple, and then I printed weekend, the slice I created, and it looks like it has created a new tuple from that previous tuple. So yeah, if you slice a list, you get a list, you slice a tuple, you get a tuple. I guess that makes sense, but I wasn't exactly sure what to expect there. So that's cool. Are there any other questions?
Hey, Raphael, how do we create a tuple with just one item in it?
I mean, can't we just say, is this going to do something crazy? I feel like there's some kind of gotcha here.
Yeah, so the small trick here is if you're creating a tuple with one item, you
Do I need
to
a
end it.
comma?
Yeah, you need to end it with a comma.
Oh, that's right. Do you remember why that is?
Yeah, because parentheses normally are just for grouping. So if you just had parentheses 1, it's just going to assume you're assigning it to an integer. So that comma makes it clear that the round brace or the parentheses are meant for a tuple, not just a grouping.
Oh yeah, that's a good point. So remember we were talking about math before. You can always surround things in parentheses to make things more clear. You know, if I'm not really sure how this math is supposed to work out, I can just add parentheses around it. And then that makes it more clear, you know, do this first before that. But I guess when you're just defining a tuple, it's unclear to Python if this is a tuple with one item, or if it's just the number 1 that I want to be evaluated first. And so I put it in parentheses. So just to make it clear to Python which one of those things I'm supposed to do, because the parentheses are used for multiple purposes, I have to put a comma after here. And then that lets Python know that this is a list-like thing. It's a tuple with one item. Cool. So that looks like that worked. Question?
Yeah, just a quick one. To access items in the tuple, you can just use bracket notation, like one item bracket 0.
Uh-huh.
Okay.
So let's look at days of the week 3. So yeah, that's using bracket notation to index into a tuple. Any other questions? Question. All right. So let's talk about dictionaries. So dictionaries in Python are super powerful. They're super useful. Really, these are going to be useful for you in any programming language, but they have slightly different names in the different programming languages. So a dictionary in Python is like an object in JavaScript. It's just a set of key value pairs. Although note that, so Python also has objects, although objects in Python are quite a bit more complex than objects in JavaScript. So some of this terminology might get a little bit tricky as we're moving back and forth between languages. But so generally, whereas a list is used to store multiple similar things, a dictionary is commonly used for storing a lot of details about one thing. So for example, let's say we want to record all of the information about a person. Might make a variable for person, and I use curly braces to create a dictionary. Keys are enclosed in quotation marks. And then the value can be whatever type I want. So note, this is a little bit different from JavaScript objects, because in JavaScript, the keys do not need to have quotation marks, but in Python, they do. All right, great. So that's a person that I've represented in a dictionary, just storing different information about them. If we want to access one particular property, we use the name of the object, and then bracket notation with the name of the property that we want to access. So note that in Python, for accessing properties of dictionaries, you must use bracket notation. Dot notation is only for objects in Python. And we're going to touch on objects later. That's not coming today. But so let's see if we can just get this one property out. Just looking for Jeff's age. .44, great. Exactly what I was expecting to see. Andrew, question?
Yeah, so in this case, even though they're in like the quotation marks, name, age, job are variables, right? They're not strings.
I wouldn't call them variables. They're strings, they're keys. They're string keys for the dictionary. Like it's possible to loop over the dictionary and just get the keys out.
Mm-hmm.
And they would be strings in that case. Andrew? Other Andrew?
So the keys always have to be a string. It can't be any other data type.
So in JavaScript, the keys are always strings. In Python, that's not exactly the case. I believe there's some exceptions. You can have other values as keys in Python. I couldn't tell you why you'd want to do that. In my mind, a dictionary is just a mapping of strings onto some other value. It's just a label for the value, essentially. So I'm sure there are good use cases for other values, and I just can't think of one right now. Good question, though. Got 2 raised hands. Shun?
Yeah, can you also put an array in dictionaries like in JavaScript?
Yeah, you can put all these structures inside of each other. So that was actually the next example I was going to show you real quick, or something similar. I'm going to put some dictionaries inside of an array. Andrew Simpson, do you have another question?
No, I just still had the hand up. I forgot I had to take it down.
Okay, no worries. So I'm going to create a list of, not days of the week, list of people. Sorry, I don't know why autocorrect is so aggressive. People. And then inside of my list, I'm going to put some dictionaries here. Note the indentation. It's the only way I'm able to read my own code and understand what's inside of what. So I'm just going to define some people. So Alice is also an influencer. Got Bob. He's a dog walker. And Carol. She's a life coach. Okay. And so now if we want to access a specific item from this dictionary, I'll name the dictionary people. And now people is an array. It has numbered indices. So let's say I want to get the second one. That's the person at index 1. I do person at 1. And now that object, people at 1, is a dictionary. And so this is going to have string keys on it, which I can also access with bracket notation. So we'll just change that on here. So that should get me Bob's name is what I'm expecting. People 1 at name should be this property right here. And that's exactly what it does. So I have accessed some nested data in an object in an array. I saw a couple hands go up, I think. Questions? Porphy, got your hand up?
Yep. So when does the white space sensitivity actually come into play? Because I think everything we've done so far still is using like brackets and curlies and such.
I'm sorry, I couldn't hear you. Could you repeat that?
Yeah, when will the actual like white space sensitivity in Python kick in? I'm just seeing that we're still using like, even though we did indent, we're still using like the curly brackets. Is that just to tell it this is going to be a dictionary? It won't just know that based on the formatting?
Right. So for dictionaries, you do need curly braces to enclose the dictionary. That's what makes it different from a list or a tuple or whatever. But it's for logic where we don't use curly braces. So we'll see that shortly in this lecture. But for if-else statements, for loops, those kinds of things, we're going to use white space instead of curly braces or semicolons. So yeah, for our data structures, we still have these opening and closing things. Good question, though. Any other questions before we move on? All right, so let's talk about functions for a few minutes. This is going to be the last data structure I covered today. And then we're going to talk about logic a little bit more. So as you know, functions in programming languages are how we do things. It's how we define some logic that can be reused later on in the same or similar circumstances. So it really helps us save a lot of work. Generally, most of the programs you write are going to be a whole bunch of functions that call each other. So it's really important that you know how to define them. So now in Python, the way we define functions is a little bit different. We're going to use the def keyword to define a function. and then the name of the function. And then you need some parentheses to say the arguments for that function. That is what values can be passed in when it's called, the information that it operates on. But this is a pretty simple function first. I'm not going to give it any arguments. It's just going to do what it does regardless of what you tell it. A colon, and then you indent. So this is the first time where we need to indent for Python to understand us correctly. Everything that is part of this function has to be indented inside of it. And then as soon as I unindent, that's how Python knows that that code is no longer part of this function. So the most important thing for a function to do is return a value. That's really why we write functions. That's why we call functions for the most part, is because we want to return values from them. This is a pretty simple function. I just want to show off the basic mechanics before we do anything wild. So this function is just going to return 5. So I'm just going to call give me 5. So what are we expecting to see now in my console when I run this code?
Nothing.
Nothing.
Nothing. I'm calling my
5.
function.
No print statement.
So that was a previous log. Let's get that out of there. It's Jeff's age. But yeah, so give me 5 is returning 5, but it doesn't print it out. It's accessible to other parts of my code, but I still need to explicitly put it on the screen. So I need to print it. Did I see a hand go up just now?
Just real quick, so we can use camel case?
No, you can't.
Gotcha.
That's definitely not something you can do. Sorry, I write a lot of JavaScript.
No worries.
So this is how you should be writing your variables in Python. So yeah, now that I'm printing it, it'll actually return 5 and print it out on the screen. So that's great. So I'm going to make this a little bit more sophisticated. So this function is going to take in, this function has one parameter, n. So typically when you're defining a function, we call these parameters. When you're actually calling a function, the values you pass in, those are called arguments. So here we're just going to return n plus 1. So this is going to take the number that we passed in, this 10, add 1 to it, and then return that value. And then we're printing it. Great. That's exactly what I was expecting. So when we pass in arguments like this, these are called positional parameters because the order actually matters. What position the parameter is in is very important. But there's only one parameter there, so it's not easy to see. So I'm going to define a new function with 2 parameters. All right. So simple function that takes in 2 values and then it interpolates them into a string. So note that the number is first and then the color is second. So when I call the function, I have to pass them in that order. So now it renders intelligible output. I can read this like English. I have 3 blackberries. That makes sense. Great. If I tried passing in arguments in the other order, I have blue 4 berries. So that doesn't really make sense to me. My string interpolation didn't work out quite correctly because I passed my arguments in the wrong order. So maybe you don't want the order to matter. You want people to just pass in arguments in any order they want to. There's a different way that we can define our function so it works like that. We're going to use something called keyword arguments. So here we're going to give them default values. So if it's called without these being specified, these will be the defaults. But also, it lets the person calling this function pass these values in any order. All right, so the function was defined with the number first and the color second. I'm just feeling rebellious, so I'm going to do it the other way around. I'm passing in the color first and then the number second. And it still works exactly the same way. Because the arguments were passed in as keywords, Python is able to understand which one is which and where they go. There's no ambiguity here. All right, any questions about keyword arguments before we move on real quick? I'm sorry, I can't tell if people are raising their hands or just forgot to take them down. Wow.
Yes, for the keyword argument, when you call the function, if you accidentally put in an argument without the keyword, will that still works out? Like
You're
in the
saying,
like in the correct sequence instead of using like keywords.
just try. I don't know what's going to happen, but I suspect it won't work. Oh, so it looks like it assumes that they're ordered then, if I don't give the keywords.
So it will just follow that order and like fill it out itself.
That appears to be the case. So here I don't use the keywords, I just pass them in the order they were defined. And I get sensible output. Right, yeah, great question.
You can even combine positional arguments and keyword arguments, but the limitation is, I believe, positional arguments must come first and then keyword arguments. So in this case, let's say Raphael's function had 3 parameters, n, color, and I don't know, texture. He could pass in 1 without a keyword argument if he wanted to. And the other 2 values after that, he could say texture equals, soft and color equals blue. So it is possible. Usually you're not going to see that very much, but it does make sense when maybe you have, and this happens with like built-in functions. A built-in function might take in like 40 different parameters, maybe not that many, but a large number of parameters. You don't want to specify like 39 of them just to get to the last one. So you might just specify like the first 4 that might be required, and then the next 36 might be optional, and you can specify which one of those you actually want to set, if that makes sense.
Yep.
I don't know if I caused any confusion there, but again, you can combine positional and keyword arguments as the summary of that.
Yeah, thank you. So now we're going to get into some slightly trickier situations. Let's say we want to write a function that handles an unspecified number of arguments. So someone might call it with 1, 2, or 1,000 different arguments, and we need to handle it no matter how many they pass in. So maybe some kind of logging function. So there's this special syntax I'm going to use here, star args. So the word args doesn't matter. That's just a variable name that I chose, although this is a very conventional name for this use that I'm about to use it for. What actually matters here is the star. That's not what I want. When you have a variable that starts with a star in Python, that means any number of positional arguments. So I'm just going to print args. And that's it. That's the definition of my function. This just means that I can call this with any number of arguments, and it's going to print all of them. So I've only defined it with one argument, but I'm calling it with 3. But since I use star args, it still is able to get all of those values in. Honestly, since I'm the one writing this function, it would probably be better to have it just take in a list of names instead of just an unspecified number of comma separated names coming in. But this is a tool available to you, and this is certainly something you'll see in functions that other people write. So I think it's important that you know about it. And then one last thing about functions. So just like we can write a function that takes any number of positional arguments, we can also write a function that takes any number of keyword arguments. So if you have a variable name that starts with 2 stars, this means any number of keyword arguments. So very commonly, the variable name is quargs for keyword arguments. So then inside of this function, quargs will be a dictionary, with key value pairs for all of the different keyword arguments that were passed in. So I'm going to do some printing with a nice format string. Just going to describe all the things that are passed in. Wait, sorry, actually first. So because it's a dictionary, first I'm going to have to loop over it because I want to print every item individually. So for quarg in quargs, and I know we haven't covered looping yet. That's going to be the very next thing. We're going to go more in depth on that. Quarg in quargs. So quargs is my whole dictionary with all of my keyword arguments. Quarg is a loop variable that's going to refer to each individual keyword in that dictionary. So we're going to print my key is, and then we're going to get the value from the dictionary. I know the syntax might look a little weird, and it sounds even funnier if you try to say it out loud, but this is some pretty handy Python. So then when we call it, just pass in any number of keyword arguments. Name is Dan. Age is 20. job equals skydiving instructor. Great. So I pass in all these random keyword arguments here, name, age, job. My function is not specifically prepared to handle any of them. There's no mention of name, age, or job in here, but it can handle any number of keyword arguments and it'll loop through that dictionary and print out all the keys and values. And that's what that looks like. So that's some pretty cool stuff you can do with Python. It's a lot of that is more sophisticated, more convenient than what you can do in JavaScript. The way you define functions in JavaScript is a little bit more basic. In fact, I think what Ankur showed you the other day with the default arguments, that's a fairly new feature in JavaScript, in fact, whereas Python for a long time has had very powerful, flexible features for defining functions that work in a lot of different ways. I haven't showed you everything you can do with functions and lists or whatever, because there's really a lot in Python. I'm just scratching the surface, but these are some of the most useful, most common things that I think you'll have to work with. So I just want you to have a basic toolkit that you can get started with. So I think this is about time for a break. When we come back, I'm going to talk about if statements and loops. But before we break, does anyone have any questions about what we've just covered now? Anybody? Any questions? Going once? Everyone's just a master of functions already.
I have a question, Rafa.
Yep.
So for the quark, the function, the input, is it okay to use a dictionary instead of typing all the variables within the argument?
Like if you're the one defining this function?
Like when you calling it, like you say name equals then.
Oh, just oh, kind of like the previous question that was asked. I don't know. Let's see what happens. So who am I? And then if I just pass in a dictionary instead. Let's so I just do it like that. Let's see what happens. Oh, gotta put quotes on these guys. Yeah, so it doesn't like that, doesn't work the same way. Takes 0 positional arguments and I passed 1. So yeah,
So
it's
it
not able
has
to
to
convert
be-
that.
Okay, so it has to be like manually put in all the
Mhm.
key and values. And for the for loop, are the quarks like the wording, are they have to be stays the same whenever you use this type of function, where they can be like used differently?
It's whatever I named it up in here, just star star, and then whatever the variable name is. I could have called this keyword dictionary.
So they can be changed as needed.
Yeah, although quargs is a very conventional name for this star star and then unspecified number of keyword arguments.
Okay, thank you.
Mhm. Any other questions?
I've got one.
Let's hear it.
How does, so for the quarks thing, I'm trying to wrap my head around it. How does it know that it's a key value pairing like an object in the first place? Because it seems to me like you're just putting in variable equals this, but when you do your for loop, it's doing it sort of, maybe I'm thinking JavaScript, it's thinking like it's like a key value pairing already.
Right, that's kind of the magic of the star star, is that whatever I pass in, all the keyword arguments that I pass in, because I did not actually define multiple keyword arguments, but I just defined star star and then quargs, Python is going to take all of the individual keyword arguments I passed in and then package them up into a dictionary before my code starts running here.
Yeah, that helps a lot because like even in your example above, described varies, it does something different with the same things being passed through.
Yeah, because here I'm actually just I'm actually declaring multiple specific keyword arguments. So the function knows specifically what it should be expecting. Porfi, do you have your hand up?
Yeah. So in the for loop, is quarg like a set keyword in Python that will always call the key? Or is that just like you chose the word quarg, but it could be anything?
I chose it. Quarg is my looping variable. So when I started doing my loop over the dictionary for quarg in keyword dictionary, I'm choosing my loop variable. It could be called whatever I want. For so this is my loop variable. In every iteration of the loop, it's going to take on the value of the next keyword key.
Gotcha. So it's looking, because you did the star star, the first variable that you put in that for is the initialized one. So it's basically saying my, then looking at keyword 0 is, and then it's checking the dictionary for this numbered key.
Yeah, because I use star star. Keyword dictionary is a dictionary, so it's iterable. I can loop over it with for, and then yeah, the first thing you need in your for loop is to define your loop variable. It can be called whatever you want, and I chose this one keyword.
Gotcha. Thank you.
You're welcome. Any other questions right now? All right, cool. So it's 11:15 right now. Let's take a 10-minute break, come back at 11:25, and we're going to talk about logic and loops. Hello, class. Welcome back. Hope you all enjoyed your break. So now we're going to start talking about if statements in Python. They're not super complicated, pretty similar to how they were in JavaScript, so I'm not going to talk about this forever. Just going to define a function here. It's going to have some conditional logic in it, so we can kind of look at some if statements. Writing a function that's going to determine if you are old enough and in the right country to drink beer, because this depends on various laws and circumstances. All right, so there's just my first line of logic. I'm going to test this before I finish it. All right, so that works so far. I'm able to pass in 21 for age. That passes this if check that age 21 is greater than or equal to 21, and we return true. Great. So some things you might notice here immediately, some differences from JavaScript. We don't put parentheses around our condition. That's the JavaScript thing. Python is a little bit more elegant, doesn't require all that punctuation, but we do have to have this colon at the end of it. So I guess it's a little bit like an open brace that starts a block, but this is the way we do in Python. No parentheses, just a colon. And then we have to indent underneath. This is the only way Python knows what is part of this if statement, what is conditional on this being true. And then anything that's unindented doesn't depend on the if statement. That's going to happen just regardless afterwards. Now let's make this a little bit more sophisticated. Going to add a second parameter. So now there's a second consideration here. You can be either older than 21 or be older than 18 and live in Canada. So there's two ways that you can potentially be served a drink depending on where you live and how old you are. But now we can see some other differences between Python syntax and JavaScript syntax. This isn't really like groundbreaking or anything, but whereas JavaScript uses double ampersand, double pipes, and the bang operator for and, or, and not, Python uses and, or, and not for logical statements. So some people find that a lot easier to read because it's just English instead of these weird symbols. I don't really think it's much different either way, but this is how we do things in Python. Now, if I want to have multiple conditions that are dependent on each other, so I don't want to run this logic unless the previous one failed, I'm going to do an elif. It's like an else if, except just everything is more concise and efficient in Python. So we're going to skip a few letters. Well, actually, before we do that, we'll get an else in here. We need to have this base case. You know, if we don't determine that yes, we can serve them beer, then the alternative is no, that we can't. So I'm going to put that in an else. So let's just see that real quick. All right, it gives us true and false. Okay, that's what I was expecting. The first person is 21 in the USA, they can drink. Second person is 20 in the USA, they can drink, or they cannot drink. So that hits this return false. Like I was shown before, elif. Let's get a third case in here. Say you're in Antarctica, and we just return true. It doesn't even matter what your age is. I don't think there are any laws over there, so like nobody's going to stop you. So if you're 2 and you live in Antarctica, that should also return true. All right, so that's how conditional logic works. I'm not sure if that's actually how Antarctic law works, but I'm a programmer, not a lawyer. So again, pretty similar to JavaScript. I didn't want to spend too much time on this because I know you've been reviewing it yesterday and really for the whole pre-work, but just some of the syntax is slightly different. So I wanted to call that out. I'm ready to move on to for loops. Does anyone have any quick questions about conditional logic in Python? Brendan?
Yes, the question I have kind of goes over what we just did. So for this else stuff with your quar type thing, could you put in like double star section where country is and then just make a list of them and make it to where it just
I'm sharing it off with my
will answer all of those at once, if that's clear.
Sorry.
I don't know,
That's
it
why
looks
I
like it
have
might
these
not
cool
be.
headphones on.
You're saying you want to
like
see
keep
something
it-
like this?
No, more
The
where
place is
Canada
back.
is. So like in the argument section.
So
So you can have a list of your countries that it would equal, or is it similar to JavaScript where you would have to do that elsewhere?
you're saying like You're asking something like that?
That, so I'm not being clear if I'm saying where you initially have if age equals this or age equals 18 and country equals, could you put a variable in there and then have your list, I guess, of where it would equal? I don't know. If that doesn't seem logical, I guess.
Are you saying like if I could have a list of conditions instead of just check them individually, like or and?
Yes, with that, because you're able to do the 2 stars and have a list of things. From it.
Yeah, there's probably a way to do that. So I might pass in like a dictionary of functions. And then like each function would be a condition that like, returns true or false if the country is the right place, returns true or false if your age is high enough. And then I could loop through all those functions and then make sure they all return true. It might take me a few minutes to code that out, so I'm not sure if I could do that in front of you.
No, I just wasn't sure. I've never used Python, and having just seen that before, it seems like it might be efficient there, at least to me.
I can see what you're getting at. If this program was much more complicated than it was, like if I actually had 100 different conditions that I needed to check, I would certainly find a more elegant way to write this than 100 else if statements. So there's probably a way I could pass in a dictionary of conditions that could be checked in a loop instead of what I've done here. Thanks. Bao?
So this question might be a little bit confusing. So in JavaScript, like we can, when there's multiple conditions, I think I use like parentheses to wrap around. So that way we can like say it's either meets this group of condition or that groups. However, if in Python, there's like multiple conditions, how would you do it if you're trying to like separate entire list of condition to like different portions? Like, are you still able to use parentheses around them?
I'm not sure if I understood your whole question, but we can use parentheses in logic in Python, so this should be perfectly valid. It's not necessary, but it should add more clarity to it. So yeah, that returns true. You can drink beer if you're in Antarctica. So I just add parentheses to make it clear that this is one thing that's evaluated. This is another condition, and then either of them can be true. So the difference from JavaScript is I don't have parentheses around the entire if statement condition, but I can use them internally to separate the parts of it.
That makes sense. Thank you.
Yep. Any other questions? All right, so let's talk about loops a little bit. Looping is another one of the really great features in Python. One of the things that's a little bit more elegant in Python maybe than in some other languages. So this is another one of those things where when you hear people talk about how much they love Python, one of the things that they're probably talking about is all of the different ways you can loop and the different convenience methods that they provide you. I'm just going to show you some basic ways you can loop in Python though, but hopefully this will inspire you. So let's see, we've just got a basic list. Just want to make it really easy to see which position each of them is in. So we're just going to use some letters here. And then to loop, we don't have to use the JavaScript style syntax, the C style syntax, where you have like the semicolon and the loop variable I that increments and loop condition or whatever. Python loops are a little bit more high level, they call them. Should be a little bit easier to read, understand like English. I say for, and then I declare a variable. This X didn't exist before right now. I'm creating it on this line, 147. This is my loop variable that's going to represent each individual item in my list one at a time. So I'll indent to show that this code is inside of the loop. Print X. So only stuff that is indented here actually happens multiple times in the loop. That's the only place where I have access to X. So that just prints out each of the letters one after the other, like you might expect. Sometimes you don't have a list beforehand, but you just know you need to do something a specific number of times. So there's a built-in function in Python that can help you with that, called range. Or from 0 to the number you specify. It's for looping. We'll take a look. Print range 10. What does that give us? Not exactly what I was expecting, but let's put in a loop and see how that looks instead. Okay, so now I call range 10. It should give me something I can iterate over that gives me the numbers from 0 to 10. And we're just going to print them out. Let's just see what that looks like. Okay, so range 10 takes me from 0 to 9. So that's roughly what I would expect. It's as if I was looping over an array that was 10 elements long, but we're starting at 0, so the last number is going to be 9. So if you have to do a loop not over a specific array you already have, just doing something some number of times, range is a good way to do that. So one problem with these loops in Python, well, when I'm looping over the list here, is that it only gives me the letters, but sometimes you also want the index. So look at this again, gives me ABC, but maybe I also want to see that A is the 0th letter, B is the index 1 letter, C is at index 2. There's a different looping construct that we can use to get us that information. So there's a function called Enumerate that I'm not exactly sure how to describe it. It kind of creates like a dictionary out of the list that you can loop over that has the values and also the indexes. And we can use that in a for loop, like so. So I've declared 2 loop variables here. Normally I just say for X in my list. Here I'm saying for I comma X, because enumerate is going to give me 2 variables for each iteration, the value and then also the index. So yeah, first iteration tells us A is at index 0, B is at index 1, C is at index 2. So sometimes if you're doing a more complicated looping problem, you need to access both the value of an item and also the index in the array that it's in, then this can give you both those at once. Can be useful. Joe, did you raise your hand?
Yeah, I was just wondering if the value and index are interchangeable.
They are not. So the value is going to be the actual item in the array. So A, B, and C. The index is just the positional number where it is in the array. So this is the 0 item, this is the first item, this is the second item, or at index 2. You see what I'm saying?
Yes, thank you.
Yeah. So that's why I used letters in this array instead of numbers, because if it was an array of numbers, it would be much more confusing to tell the indexes from the numbers themselves. Are there any other questions? No? Okay. Let's move on. So I showed you this before very briefly, but I'm just going to explain it one more time. You can also loop over dictionaries using pretty similar syntax. All right, we've got our dictionary of food reviews here. If we want to loop over these, similar kind of structure, a for loop. So our loop variable here is just going to refer to the keys. It doesn't automatically give us the values, but that's fine because we started with the whole dictionary, and given the key and the dictionary, we can get the values out of it. So for key and food reviews, I'm going to print food reviews at key. So it's not the string key, K-E-Y. This is a variable that refers to something else, but that's the index. That's the key that we can use to pull data out of this dictionary. That looks a little bit something like this. So that's just printing out the values. If we want to also get the keys, print the key first, and then food reviews key. And then we'll just print a little separator here. So yeah, key, value, key, value. That's how you loop over dictionaries. See, Python also supports while loops. These are very similar to JavaScript, so I'm not going to talk about these for too much. You have some condition in your while statement, and then a body for your while loop. And this body is going to run repeatedly until this condition is no longer true. So you had better make sure that there is something in the body of your while loop that can make the condition false. Otherwise, you get an infinite loop. So yeah, that's our simple while loop, counting down. Although, like Ankur said the other day, since in this case we know how many iterations we're doing ahead of time, this would have been better done as a for loop. Typically, you use a while loop when you don't know ahead of time how many iterations you're going to do. But I just wanted a simple example of showing you the mechanics of a while loop in Python. So honestly, typically, I don't use while loops very often in practice because most of the time when you're writing a loop, you will know ahead of time how many iterations you need to do. So for loops, in my opinion, are much more commonly used. Did I see a hand go up?
Yeah, I have a question back in the dictionary for key and food reviews. So it looks almost the exact same as looping through an object in JavaScript. Almost.
I mean, yeah, it is.
Are there, I just wanted to know if there were like any differences that we needed to know between like the two.
Not that I can think of. Objects in JavaScript are very similar to dictionaries in Python. The way you interact with them is very similar. I mean, we have quotes on the keys in Python. You don't do that in JavaScript. Otherwise, they're very similar.
All right.
Was there another hand up? No? Okay. There's a little bit more I could say about while loops. They do have some other features, some keywords and complexities, but honestly, excuse me, I just don't think while loops are super useful and we're kind of running out of time. So I'm just going to discourage you from while loops and we're going to talk about some built-in methods instead. So I might have shown you a couple of these throughout this lecture, but we didn't talk about them explicitly yet. But many different types of values in Python have built-in methods that you can use to manipulate that value. Now, a method is simply a function that belongs to an object or that belongs to some other value. So before I start showing you stuff, you should know that there are two different types of built-in methods you'll need to be aware of. Okay, so two types of built-in methods that you should be aware of. There are destructive methods, which will modify the data of the value that you call them on, and non-destructive methods, which will not modify the data you call them on, but they return a new piece of data. So let's see if we can see some examples of that. I'm going to define a variable in Python here. First name equals Jonathan. Now, Jonathan is a string, and there's a whole bunch of methods for strings in Python. If you Google it, I'm sure you'll find a lot of documentation, a lot of articles. Don't go to W3 schools. Let's go to docs.python is probably good. MDN is also good, but I didn't see them come up. So yeah, these are all string methods. There's a lot of stuff you can do with strings. It is not your job to know all of these, but just when you're working with strings and you're struggling, you think like, this should be easier. There's got to be some tool out there to help me. Maybe look up the string methods and see if there's something that seems it's appropriate for your problem. And over time, you'll probably find yourself using similar methods over and over. You'll decide for yourself that some of them are more useful than others. Right now, I'm going to just show you briefly capitalize. This one at the very top of the list can actually be pretty useful in a lot of situations. I'm going to call first name dot capitalize. So this is supposed to, convert the string to a capital string or possibly just the first letter. Might be a little different than in JavaScript, but let's see what happens. What are we expecting first name to look like?
It's going to be capitalized.
That's a reasonable assumption. But it's not. So capitalize is a non-destructive method. It doesn't actually modify the data that we call it on. It just creates a new string that actually does have those changes to it. So instead of just calling capitalize here and then doing nothing with the results, I'm going to create a new variable And then that's going to capture the return value of capitalize. So we're printing the original value first name and then the new value that we just created. So there you can see that we have actually capitalized the first letter of Jonathan's name. So we can see here that capitalize is a non-destructive method. Now it's really important to know which ones are which, because you don't want to think you're returning new data and then accidentally modify your original data. That could be really bad. So you have to either read the documentation or just test these out, write a little test file, call some functions, see what they return. Maybe they return nothing. Maybe they modify your original data. It takes like 5 seconds to just test it out and check, compared with hours and hours of debugging if you use the wrong one in production. So let's look at a slightly different example here. So strings also have a method replace, which does roughly what you expect it to, does what it sounds like. I'm going to do some replacing. Then I will print last name. Now note that I'm not assigning this to a new variable. I'm just calling the function, letting it do what it does to last name, and then we're going to see how it's affected. I thought that was going to be destructive. Let's see what actually happens here then. Okay, so again, replace is a non-destructive method. It does not actually change the string that we called replace on, but it just returns a new string instead. So I'm actually not sure of any destructive string methods offhand. Maybe they all just return new strings. But when we get to lists, it's a little bit more dicey. You'll have to pay more attention. So if we have a list, like staff equals so definitely a destructive method is append. This is going to add a new item to our list. It's kind of the equivalent of push in JavaScript. And so this is definitely destructive. The whole point of the append method is that I'm trying to modify the array. I want to add this extra item to it. So I'll print my new array, and I haven't assigned this to a variable or anything. I'm just calling append on the staff array. You can see now that the array has changed. It has this new value in it for Alicia. So you've got to be careful if you're doing lots of popping or appending, that is definitely going to change the array. So I'll just do that twice, then print out staff again. And then you can see between the first time we print it and the second time we print it, 2 items have been removed off the end of the array, because that's what pop does. It is a destructive method that removes and returns the last item from the array. Or from the list, I'm sorry. So I just want to introduce to you the concept of built-in methods. Just understand that some of them create new data, some of them will modify your original data. There's a whole bunch of useful ones. You will probably not use most of them though. Let's see, for strings, find is probably something you'll need to do at some point if you're trying to find substrings within a larger string. Split and join are pretty useful. That's for turning a string into an array and then turning a string into a list and then turning a list back into a string. That can be useful for some problems. Because you can't assign values to a string, but you can assign to an array. You can just manipulate an array more flexibly than you can a string. So for lots of algorithmic problems where they ask you to manipulate an array or where they ask you to manipulate a string, what you actually have to do is convert it into a list and then manipulate the list, then convert the list back into a string, just because it's hard to manipulate strings. But it's easy to convert them into something that is easy to manipulate. So split is useful. Join is like the opposite of split. Turns your list back into a string. But list methods are also super cool. So we've seen append, remove is nice, pop is very important. Sort is super important. It's a little bit harder to use the sort method in Python than it is in JavaScript, but however you're going to do it, it's important that you know how to sort things in a list. I honestly feel like 90% of the work that a junior developer might be asked to do is really just sorting and filtering lists and then finding a pretty way to display them on a page. So I would definitely recommend that you are comfortable sorting lists by any arbitrary criteria. Copy and reverse are pretty cool. So yeah, if you're working with lists and you feel like you need to do something that's hard to do, maybe check the built-in methods, see if there's something that'll help you out. Yeah. All right, so that is all I have for you for today's lesson about introductory Python. I hope this was enjoyable and not too super boring, because I know you just learned all the fundamentals yesterday, but we can open up for questions now. Shun?
Yeah, so is there a scenario where you would use one language over the other, or is it up to like preference at that point?
I'd say both of those are true. So there's certainly some hard limitations in when you have to use certain languages. So for the front end of your website, JavaScript is the only language that'll run on the front end of your website. So you have to use JavaScript there. Now, that being said, there are other languages that compile into JavaScript. So like TypeScript is something you might have heard about. That is not a language that browsers understand, but people have found ways to write TypeScript and then convert that into JavaScript. So they get to write the code they want to write and still have browsers understand it, but it's still really close to JavaScript. Something that would be a bigger leap would be like writing Python on the front end, which I don't think there's any way you can do that. I've heard of people trying to write C# on the other end, on the front end, and that just sounds like madness and is super buggy. Don't try to do that. So for practical purposes, JavaScript is the only language that works on the front end. For the back end, you have a lot more choices because that's not your user's computer. The back end is your computer, so you can install whatever server framework you want on there, but you're still kind of limited by the communities out there. Like there's a really strong Python community, and there's a lot of great Python developers building backend tools for you to use. So Python, will be a great backend language. JavaScript would also be a good backend language because it has a really robust community. Bash. So I taught you Bash a little bit in introduction the other day. Technically, Bash is a full programming language. Technically, you could build an HTTP server in Bash that takes requests, sends response, build a full web application just running Bash on your backend, and you'd probably drive yourself crazy in the process because there aren't any very good tools that are already written for building a web server in Bash. You would be doing it all yourself by hand at a low level, manually handling the connections and the responses and setting every header. And it would just be a ton of work to do simple things. So while it's technically possible to build a web server in Bash, that would be a terrible idea. Does that answer your question?
Yes, thank you.
Other questions? Jen? I think you're muted.
So is it pretty important to know which methods are destructive or non-destructive when you're just working on code?
Yeah,
So like you're not messing up any data.
right. So that's, I mean, it's the difference between, like, let's just look at this capitalize method. Since I know capitalize is non-destructive, this is how I have to call it. Call first name dot capitalize and then assign it to a variable because I know it's not going to change first name. It only returns a new value. So I have to assign it to a variable in order to make that value, in order to store that value. If capitalize was a destructive method, I would just call it like this. Without assigning it to a variable. And then in the later lines of code, I would just continue manipulating first name, knowing that it had been changed by capitalize. And also just a little warning, I think I might have mentioned this the other day, but in JavaScript, the sort method, which, very powerful, very important, you should learn how to use it. For some reason, the JavaScript sort method will both modify the original array and return a new array. So it's like a combined destructive and non-destructive method. I don't know why it does both of those things, but that's kind of one of those weird gotchas about JavaScript that you'll have to be aware of. Do we have any other questions? Going once, going twice? No, okay, great. So that's all I've got for today's lecture. Hope you enjoyed it. Feel free to take lunch. We don't have anything planned for this afternoon, so just come back at 5 for stand down. Have fun.